Hi all, in this video I am going to explain concept learning through the algorithm called as Finder's algorithm. To start with, what is a concept learning? Concept learning is a fundamental task in any machine learning problem where the goal is to find or learn a general description from the given training samples so that the hypothesis or the concept what we learned can be able to work for the unseen data. So every example in the training sample have the set of attributes and also the labeled. Either it can be a positive class or a negative class. This label what we are learning is called as a concept or a target through the training samples. And this concept learning is used to explain how the machines generalize the knowledge from the experience learned from the sample data in order to classify the unseen data. And the concept learning will be identified as a search. It can be represented as a search space which contain the hypothesis. So here it will be called as the hypothesis space. And the concept learning is acting as a task of searching the potential hypothesis, that is nothing but the consistent hypothesis which can be applicable for all your training samples, or it will best fit for the training samples. And this hypothesis space having multiple hypotheses. So through the concept learning, we have to identify the hypothesis which is best fit for our training sample. To know about the hypothesis space, first we have to know what is an instance space. So instance represent the possible input attributes for the every input features. So if I take a sky, it having two different input attributes, sunny and rainy, and air temperature have the possibility of warm and cold. So we have two. So the instance space we can possibly make 4 instances. So how we have to write the combination, that is sunny and warm, and then followed by sunny and cold. And similarly we have rainy and warm followed by rainy and cold. So these are the various possible instances available in our instance space. So similarly we have to form the hypothesis. So basically the hypothesis having only the input attributes. So it can be a combination of sky with the air temperature. So the values of the hypothesis can be of anything from the input attributes of sky with sunny or rainy, or air temperature with warm or cold. So apart from that, we have specific hypothesis and the general hypothesis. So if I have the question mark, it is a general hypothesis, and if we have this symbol, it is called a specific hypothesis. Or we can have a combination of our instance along with a specific or the general. So we have to form how many syntactically distinct hypothesis spaces we can form from this given input. So in the sky attribute, already we have sunny, rainy, along with we have the possibility of specific and also general and the specific. And same thing for the air temperature, we have warm, cold and also general and specific. So totally 4 into 4 we have 16. So how we have to form this? The same combination we can with sunny, question mark, then we have sunny, then specific, then we have sunny, warm, followed by sunny, cold. And we have to repeat the same thing for the rainy. So rainy, question mark, then rainy, this thing, and then followed by rainy, warm, and we have rainy, cold. And similarly we have for the combination for the question mark. So question mark and then this thing, then question mark, warm, then question mark, cold. And we have the combination with the specific, question mark, then specific, specific, then specific warm, and then followed by specific cold. So totally we have 16 distinct hypothesis spaces. So these hypotheses are only available inside the hypothesis space. So through the concept learning, we have to identify out of this hypothesis, which hypothesis will be the consistent hypothesis that will be best fit for our input data. That only we are going to do with our finders algorithm. And the next hypothesis space is semantically distinct hypothesis space. So semantic means meaning wise it has to be distinct. So when I have anything with specific, it will be generally we can reject that hypothesis. So I can have this thing, and also this. All have the similar meaning. So any combination with a specific, it will be a reject concept. So I can have at least one specific hypothesis is enough. So now you can see here in the first combination, you may have sunny, rainy, along with question mark, then warm, cold with question mark. Any combination with this pi, we have to consider only once. So for the first attribute 3, second attribute 3, and we have one specific which is suitable for everything. So we have only one combination. So totally 10 semantically distinct hypotheses. So first one is the instance spaces. Next one is syntactically distinct hypothesis space, and the last one is semantically distinct hypothesis space. So now we are going to see how to use the finders algorithm to create a consistent hypothesis for the given input. Finders algorithm basically start with most specific hypothesis and it will move to the generalized way, and also it will consider positive samples only for learning purpose. So here this is our input and this is our target or the concept which to be learned, and through this we have to create a consistent hypothesis that has to fit for the all our input samples. And this is the positive sample, this is a positive sample, and this is a positive sample. So whenever there is a positive sample, we have to rewrite the hypothesis. Whenever the negative sample, we have to retain the hypothesis. No need to change the hypothesis. And also we are moving from specific hypothesis to the general hypothesis. So to start with the initial hypothesis, we are going to have only with the input attributes. Totally we have 6 attributes. So we are having 6 specific symbols. And now the first input is x1, which is a positive target. So whenever the input is positive, we have to rewrite, because when I use this h0 as a hypothesis to pass this input, sunny match with specific, it will reject it. So when any one input get rejected, my output become no. But the actual target what I expect is yes. So we have to rewrite this hypothesis in order to accept the x1 to get the target output is yes. So if I want to rewrite this specific, I am going to change with sunny, warm, normal, strong, warm, and same. So now this hypothesis, when I pass this x1, the x1 will match with h1 hypothesis. So it will produce the output as yes, my target also yes. So this step, the hypothesis h1 able to satisfy x1. So now we are moving to the step 2. Here the previous step hypothesis, that is H1. Now I am going to consider with the sample X2. So again, X2 is a positive sample. If it is a positive, we have to rewrite the hypothesis so that this hypothesis has to accept X2. So now you see, when I pass X2, what happens? Sunny, sunny get match, warm, warm match, but high and normal get opposite, so it get rejected. But my actual output is yes. So I have to rewrite the hypothesis in order to accept this input. So when I rewrite sunny, it get accept no problem. Warm, it get accept no problem. But normal and high, which is an opposite sign. So to accept both of them, I have to go for the general symbol. So next is strong, and next is warm, and next is same. So now if I try to pass X1 in H2, you see here X1 sunny, warm, normal, and it is anything. So both will pass. So strong, warm, same. So it get passed. The output is also, target is S, output is also S. So when I pass X2 to the hypothesis H2, that is also sunny, warm, normal. We have high, but our hypothesis having question mark, so it can accept anything. So that also get clear. Now we are moving to the step 3. So step 3, our hypothesis H2 is there. Now I am going to consider X3. So X3 is a negative sample. So we are not going to change anything in our hypothesis. So I am going to just retain the hypothesis. So I am going to just take the same hypothesis what I am having in the previous step. So strong, warm, and same. So now see here, up to this level, the H3 can able to pass X1. That is, if I pass X3, it is pass. X2, that is also get pass. So when I pass X3, see here, rainy, and our hypothesis is sunny. So rainy and sunny is opposite. So automatically the hypothesis is not accepting the input. So your output is no. Our target is also no. So now we are moving to the next step, that is hypothesis H3 is there. I am going to consider the input X4. So X4 is positive. So we are going to rewrite the H3. So when I rewrite H3, H4 is equal to sunny, sunny, match. So no problem. And then warm, warm, match. Then we have high question mark, it can accept. So I'm not going to change this symbol. Then strong, strong, accept. So it get matched. Here you see here, this is cool, this is warm. So if I use the same hypothesis here, it will reject my input. So I have to rewrite in order to accept the cool instead of warm. So I am going to put the question mark. Then last one, see here, it is change. Here it is same. So that also I need to change it to question mark. I think it's clear to you. So this input sunny matching, warm matching. This input question mark can accept anything. Strong, strong matching. But here my inputs are opposite. So to accept my input through this hypothesis, I have to rewrite the hypothesis to the question mark. Change, same. It is also changed to the question mark. So now this is my final hypothesis. I am going to check whether it is consistent. So I am trying to pass my X1. Sunny, pass, warm, pass, normal, replace with question mark, strong, question mark, question mark. So my output is S, target is also S. Going to the next input, sunny, warm, question mark, then strong, question mark, passing anything. This is also passing anything. So X2 also passed. Then coming to the input x3, and here itself rainy and sunny both are opposite. So my output is no, my target is also no. And the last one, I'm taking the instance x4, sunny, warm, high will be replaced with question mark, strong, warm will be replaced with question mark, change will be replaced with question mark. So I'm getting S. So now I can tell this is the consistent hypothesis what we learn through the positive samples from our training samples in order to learn the concept or a target using the finders algorithm. So we have formulated H0, H1, H2, H3. These are all in the hypothesis space. So we are doing the searching through the concept learning and we are identifying the consistent hypothesis which will be best fit for all our training samples. Now you can see this is the algorithm for the finders algorithm. First we are initializing with the specific hypothesis. We are considering only the positive samples and we are comparing the hypothesis with the each attribute. If it's satisfied, we accept. If we are not satisfied, we move or we change our hypothesis to the general constraint, that is with the question mark. We are not consider negative samples here. And the finders algorithm having some limitation. Okay, so what is the limitation? One of the thing is we are not considering the negative samples. And you see here, is there only one consistent hypothesis for a problem? You can see here, this is one of the hypothesis and this is another one and this is the next one. We see here, x1 we pass here, sunny, warm, normal, strong, so it get cleared. We pass x2, x2 also it get cleared. x3, rainy and sunny get rejected and x4, it is also passed. And we consider this hypothesis. So now this is a consistent hypothesis. And we consider this one, pass x1. So x1, we have everything. x1, we have a strong, remaining all question mark. So it can able to do for x1, x2, x3 and x4. You see here x3, x1, x2, x4, it will pass. But when it comes to x3, strong and strong. So the output you get is x. But the expected output is no. So this hypothesis is not a consistent hypothesis because it cannot best fit for all your inputs. And now you see here the last hypothesis. So we have question mark and then we pass x1. So first one is question mark, warm, question mark, strong, warm. So it will pass. x2, we have the question mark, warm, high, strong, warm, same. Good. So x3, we have question mark. Here we have cold and warm. So it get rejected. My output is also rejected. And the last one, x4, we have matching with our input with the hypothesis, sunny, warm, high, strong. Everything get matched. So now this hypothesis also a consistent hypothesis. So you are not sure how many hypotheses are consistent inside the hypothesis space. What are the other possible consistent hypotheses also available? We have to find out. So that is one of the main limitation in the finders algorithm. So to overcome that limitation, we have the next algorithm called as candidate elimination algorithm. So these are some of the limitations. Since it ignoring the negative samples, we are not able to redefine the hypothesis based on the negative samples. And also it may prone to overfitting because it may produce the hypothesis too specific to the positive samples because it will be considering only, it is learning only the positive samples. And also there is no guarantee of the best hypothesis because the only one hypothesis what you produce through the finders algorithm may not be the appropriate or the final consistent hypothesis. So to overcome that only, we have the next algorithm called as candidate elimination algorithm. Thank you.